Here we have two examples where we are asked to rank these in terms of bond length, from 1 is the longest, and energy, from 1 is the highest energy. So in order to do that, we need to go ahead and consider two different cases. In the first case, we have hydrogen bonded to fluorine, bromine, and iodine, which go down in the halogens on the periodic table and get larger. In the second case, we have a CO single bond. We're looking at this particular bond, a CO triple bond, this particular bond, and a CO double bond, this particular bond. On your screen, you'll be able to see them better than on here, because here they're not. This is in color, printed in color. So we have two different things going on here. So let's look at bond length first. So since iodine is bigger than bromine or bigger than fluorine, this is going to be 1 or longest, followed by 2, followed by 3. Because iodine is larger than bromine is larger than fluorine, so this is the order of bond length. The shorter the bond, the higher the energy of the bond. So the bond energy is going to be exactly the opposite. Since HF is the shortest bond, it's the highest energy. HPR is second, so it's the second in energy, and HI is the longest bond, therefore it's the lowest in energy. So they're exact opposites. It's the same thing, or something similar, for comparing a single, a double, and a triple bond. In this case, a single bond is the longest. A double bond is shorter, and a triple bond is even shorter still. The energy, again, is exactly the opposite. Since a single bond is the longest, it's the lowest in energy, followed by a double bond, followed by a triple bond. As you get more bonds from single to double to triple, you have a greater overlap of the orbitals, and therefore the atoms actually come closer together. So the bonds get shorter.